Hey, welcome peeps. I'm going to break up lesson 96 into two parts. I want to be able to give myself a little bit of time to use the technology. I'm going to use DESMOS on my cell phone, and I'm going to use the graphing calculator as well. We're going to save that to the second part. What I like to focus on today is doing the work by hand, really, and the algebra version of graphing quadratic functions, that would be parabolas. And note here, no calculators in terms of like no graphing capabilities here. We're going to do the graphing stuff by hand after crunching the numbers algebraically. The second part, I want to pull up the camera on my my calculator on my phone and kind of demonstrate some of these things and visually what happens when we do these types of things. If you go back to lesson 89's things, I spent really 2 episodes talking about some of the nuts and bolts. So hopefully today will be mostly review with that. Some of the terms that we're supposed to talk about would be the axis of symmetry, vertex, y-intercepts, and other important points. We got like 2 important points. Figure out what those things are as we go along. Also, we're going to be looking at the same, well, all quadratics, but of slightly different forms from one another, and how that all kind of plays out in the drawing of these things. First of all, we would take the form x squared plus bx plus c, or more specific, more generally, I guess, it's still the quadratic form ax squared plus bx plus c. It's just we're going to set a to be equal to 1. And that's why we didn't have an a up here, why it's just 1x squared. And b and c will be different numbers. Secondly, we'll allow for a being a number like a 2 or a 3 or a 7 or something like that. Okay, so we'll change it from just a standard 1 in the front to something else in the front. And when we've factored, we've had to take these 2 cases up. Thirdly, we'll take the same thing, except we're going to set b equal to 0. That is, it's going to take out this linear part right here. And it's only going to be ax squared and a constant. That's going to simplify things quite a bit if we happen to have one of these forms. Back in the 1500s, in Italy, when people were having math duels with each other, they would look at all the different forms of quadratics that you could possibly come up with. What if we don't have the constant? What if we don't have the b term? They weren't allowed to use negatives, so they had to have forms like ax squared equals c, or ax squared equals bx, or ax squared equals bx plus c. They had all these different ones, and then they give each other problems and say, who can figure out the most of these the fastest, and then off they'd go, and then you'd have like bragging rights for being the best math dude in town. You could like kick somebody out of their job if you were better than they were with these things. Okay, so here we go. We're going to take up our basic quadratic form, and we're going to pull some of that information out of the formula, number crunch, and then spit some stuff out that we can graph. And the first thing that they've got here is the axis of symmetry. So this is review. There's a formula for finding the axis of symmetry. And you remember I showed you the first derivative, and that's where that comes from. Now, again, parabolas all have the same shape, and they're all symmetrical. They look the same on the left as they do on the right. So finding this line, which is an x equals something line, is pretty important. That gives you at least something there where you say, okay, that parabola is somewhere up or down on this line. I can slide it up and down and find it there. So this actually is useful because when you plug in the formula, and again, we're working with y equals x squared plus bx plus c, or ax squared plus bx plus c, we take out this a number and we take out this b number and we throw them into there, and out comes this dotted line. Another important thing is that the vertex, that is the lowest or the highest point, always has the address of whatever we got there. so I'm going to put it in negative b over 2a, is its x address. Okay, and that can be found when we search up for the axis of symmetry. Superpose, that's the first thing that they want us to find. And then we also have another thing available to us here in the equation, and that would be the y-intersection. That is, where is it crossing the y-axis, if it's crossing the y-axis at all? Okay? And if it is crossing that y-axis, we want to know what it is. And that's sitting there in the formula too. Sorry, I'm not talking to you. I'm talking to my book here. But what we would do here is we would say, what if x is 0? This is the line x equals 0. It is the y-axis. It's the same thing. X equals 0 is the y-axis. So if we plug in a 0 into here, we get y equals something times 0 squared plus something times 0. Obviously, these two parts become nothing, and we just get this part right here. So in our equation, that part right there is where it crosses the x-axis. You get our y-intercept at the point 0, c. C as in x squared plus bx plus c. At 0, c, we get our y-intercept. Write that down. That is good stuff, okay? Good stuff. Hit pause if you have to. I'm going to clear the board, and then we're going to work a few problems out and just look at these few things right here. Yeah. Oh my goodness. Okay, here we go. I got my generalized picture right here. I kind of copied the information over here. I got my formula for axis of symmetry. I got what I've talked about first for the vertex, which is either our lowest or our highest point, depending on if our parabola opens up, then has a lowest point, and if it opens down, it has highest point. There's its x address. We'll talk about the y address. And the y-intercept, which would be like where it crosses the y-axis here, has the address 0, c, as in x squared plus bx plus c. So we need to know the axis of symmetry. We need to know the vertex. It's on the axis of symmetry. And we would like to know the the y-intercept. This may not be what my picture is, so I'm going to get rid of it. I'll put in a generalized kind of y and x on the small scale here, and we're going to crunch some numbers. And here's our first equation over here. X squared plus 4x plus 5. I think that's what they got in the book. And they say, graph it. And then first thing we're going to do is we've got to collect some information here. We've got to figure out what's A, B, and C. Well, A is kind of an understood one there. There's B is 4 and C is 5. So if we would like to find the axis of symmetry, we're going to plug it into the formula here, and we get negative 4 over 2 times 1. And that gives me the line x equals negative 4 over 2, or negative 2. So at the line 1, 2, x is negative 2. Oh, 1, 2. We're going to draw a dotted line here, and negative 2. There's our axis of symmetry. There's our AOS for this one right here. Secondly, then, the vertex is somewhere on this dotted line. And so we can plug in right here, negative 2. And then what we're going to do is we're going to plug in a negative 2 into the equation and see what pops out. That is, we're going to go y equals negative 2 squared plus 4 times negative 2 plus 5. We're going to evaluate negative 2 in this function, see where it ends up. We get 4 minus 8 plus 5. 4 and 5 makes 9. 9 minus 8. Y equals plus 1. Okay, so I use this x, I get this y. That's where my vertex is. So we say at negative 2, positive 1. There's my vertex. This one opens up. It's symmetrical. I guess got to find out one more point where it crosses the y-intercept, where the y-intercept is located. and it's C. So it's at 0, and then in this problem, C was 5. So at 0, 5, go 1, 2, 3, 4, 5. That's where this thing's going to curve over on this side, and it'll be symmetrical. It'll curve this way, it'll curve that way, in the same way. Pardon my drawing, it's not too hot here. It doesn't have to be, as long as I've got a vertex here, a vertex at -2, 1. I've got my axis of symmetry there at x equals -2, and I've identified that that point right there is 0, 5. It's really enough to draw the rest of that picture. Yes, indeed. Okay, I'll do one more, kind of the same setup here, and then I'll be done with this. The next episode, you'll see these pictures on a screen, and maybe it'll be make more sense. Okay, just a little bit different in that it has a number out here in front that's not a 1. It's just sitting there. So we're going to go ahead and we're going to figure out A, B, and C, and then use that information to fill in the rest of the stuff. Pretty straightforward, 3, 18, and 13. And then off we go with our axis of symmetry and whatnot. Negative B over 2 times 3. That's negative 18 over 6. Axis of symmetry is at x equals -3. 1, 2, 3, -3. There's my axis of symmetry at x equals -3. That's the first bit. Second bit, we're going to go in and we're going to use that, -3, and then evaluate the function at -3. It'll be 3 times -3 squared plus 18 times -3 plus 13. I'm going to hit pause and do the math. Bam, did while you weren't there. -14 is what I get when I evaluate that, so we're going to replace that with -14. That's way down here. I'm just going to approximate it. There's my vertex, -3, -14. This one opens up because that's positive, so it's going to go something like this, and I need to find out where it crosses the axis, and this says that it's at plus 13. Oh man! So I would have way up here somewhere. This is a really skinny one, but there you go. There's our point 0. Positive 13. Skinny because we multiplied it by 3 here, and multiplying by 3 in the front really narrows our parabola. So we use the information given in the ABC of the ax squared plus bx plus c form to find the axis of symmetry, -b over 2a, the vertex, which uses that number and evaluates the function to find the y value. It's somewhere on that axis of symmetry. We nail it right there, and then we found the y-intercepts by looking at what c was equal to. There's your answer. Okay, so we're going to take the same kinds of questions, and we are going to graphify, I don't know, is that a new word? We're going to make it graphical, whatever, visual. Just whatever. Just give me a break. It's like late. Okay? Take the same stuff and we'll do it on technology. There we go. So tune in to next episode there, and hopefully that'll round out your understanding of quadratic functions and how you can graph them both by hand and with technology.